Hi, today we're going to go through question 4 of the PAT paper from 2016. So question 4 says, what is the term independent of x in the expansion of x minus 1 over x squared to the power of 12? Okay, if you haven't seen our video on the binomial theorem, I would recommend you go and watch that. But what we know is that the general expansion for an integer power, a positive integer power of a plus b to the n, well, the general coefficient, so the general term is n choose r, a to the power of n minus r, b to the r. And in fact, we get that a plus b to the n is the sum from r is 0 to n of, undo that, so of n choose r, a to the n minus r, b to the r. Okay, so let's think about this. We want the term as independent of x. Let's write down a general term in this expansion. So a general term in x minus 1 over x squared to the 12. Well, what is that? Well, think about it this way. This is going to be our a, so this term here. And then this is going to be our b. And then this is going to be our n. So let's plug it in. So it's n choose r, so that's 12 choose some number r, times a to the r, so that's x to the r, times minus 1 over x squared, so that's minus x to the minus 2 to the power of n minus r. Okay, and we want this to be independent of x. So what does that mean? Well, that means that the term has no power of x in it. In fact, sorry, I've written n here, there should be a 12, we said that n was 12. So it's minus x to the minus 2 to the 12 minus r. So we want this term to be completely independent of x. So let's combine the powers. So that is equal to 12 choose r, and then we'll bring the minus 1. So minus 1 to the 12 minus r. We're not concerned with that for now. And then it's x to the r, and then we have a minus 2 times a 12, which is a minus 24. And we have a minus 2 times a minus r. So we get plus 2r minus 24. Okay, and we want this to have no power of x in it. So that means we require r plus 2r, or in fact, just 3r, minus 24 to be equal to 0. Why is that? Well, because x to the 0 is 1, and therefore there's no power of x in there. So this implies clearly that r is equal to 8. So we require the term of r being corresponding to 8. And therefore our term is simply 12 choose 8 times minus 1 to the 12 minus r. Well, 12 minus 8 is 4. Minus 1 to the 4 is just 1, so we can ignore that. And 12 choose 8, well, that's 12 factorial over 8 factorial times 4 factorial. And when you evaluate that, that comes out to 495.